Alright, hello again. This is Jeff Scott of Blackhawk Technical College, and I've been going over the PowerPoint presentations for the MySQL book from Bureau for the 152-147 Relational Database Development class for the spring 2016 semester at Blackhawk Technical College. So far I've gone through the first 6 chapters, so I'm going to continue on here with Chapter 7. And Chapter 7 is on how to code subqueries. The biggest thing about a subquery is a query within a query. So the reason that you typically want to create a subquery is that it'll operate faster. And when you start to think about it, queries can get unbelievably large depending upon what you're looking for. Now, I had a student, his name is John, true story, probably about 15 years ago was one of my students. And a very interesting guy. Actually, I don't know how, but my boss at the time, the dean of the business division, Larry Horsfall, met this guy. He was working in a junkyard, literally. And Larry got to know him and somehow convinced him to come to Blackhawk Technical College and go through the program. Well, he did. And after he graduated, he got a job with the Department of Natural Resources for the state of Wisconsin. And we kept in contact over the years. I haven't talked to him now probably for a few years, but we kept in contact for a good, I'd say 10 years after he graduated. And we were talking once, and he was talking to me about database queries because he just had this fascination, for lack of better words, with using databases. And that's what he got into. And he very much enjoyed his job. Okay, when we started talking, I asked him once, what is the biggest query you ever wrote? And he literally said that it spanned the equivalent, when you talk about a text being on an 8.5 by 11 piece of paper, it was about 12 pages long. And what that meant was he was going through a database that literally had millions, several million records in it, looking for one or two little pieces of data. Now that might not sound like it's very much, but think about it. That is the old proverbial, almost needle in a haystack type of an idea. And I said, well, how did you do it? And he just laughed and he said, very slowly, very deliberately. So what he did was he built the most inside piece of the query, got that to work, then added the next most inside piece of the query and built his way from the inside out till he got it all to work. And that's what we're going to talk about in here. So we'll talk about coding select statements that require subqueries, describing how subqueries can be used in where statements, and there's a lot of stuff you can do with subqueries. Now I should mention that most of the time, you could probably make a case to say all the time, but at least most of the time, what you do in a subquery, you could do without a subquery. All right, in other words, you could do it writing some kind of a different kind of query as opposed to a subquery. And sometimes the reason that you write subqueries is not so much for their elegance as far as how they look, but it's their elegance as far as how they act. Because if you're working for a place that is very real-time sensitive, that needs to get results in X amount of time, then it's very important that your queries be as optimized as possible. And quite often when you're going for that optimization, a way of doing it is through the use of subqueries. All right, so we'll talk about the way subqueries can be used, including having, from, and select. We'll talk about the differences between a correlated subquery and a non-correlated subquery. So the author says here's 4 ways to introduce a subquery in a select statement. So in other words, inside of a where statement, instead of having a condition in there, you can have another select statement. All right, so you have a select within a select. You can do it within a where or a having, and as both times as it says, you're working with search conditions. Now, what are the differences between those? With a where, you're not doing grouping. With a having, you're doing grouping. So the where, you can also have a where and a having in the same query. but then it implies that you're doing some kind of grouping, and the where does a search condition before the grouping has happened. The having does it after it has happened. Okay? All right. You can also use a subquery in the from clause, as it says, as a table specification. Or you can do it in the select clause as a column specification. You're going to see examples of all those in here. So here's an example of a where clause. Now think about it this way, all right? What we're trying to do here is we're selecting the average invoice total from invoices. Let's just say that that average invoice total happens to be $2,000. Let's just say as an example. In fact, let's make it, looking at what they have in here, let's make it $1,925. All right? So we do the innermost query first. We get the answer to that query, and then that output of that query becomes the input to the other part of the query. So again, assuming that it's $1,925, now we have select invoice number, invoice date, invoice total from invoices where the total is greater than $1,925. All right, or I guess they actually show there's the value that was returned. So that value, that 1879.74, etc., that result that's right there is what gets returned from this. And that's typically the way that you're going to end up using a subquery. We could have done this as two different queries. So in other words, we could have just written a query that said select average of invoice total from invoices, gotten that number, all right, and then literally plugged that number in. So said select invoice number, invoice date, invoice total from invoices where invoice total greater than 1879.74. Could have done it that way as two different queries, but since it's two different queries, it would take longer. So again, one of the main reasons that you are using subqueries is because of speed. So here's a query that uses an inner join. We're getting the invoice number, the invoice date, the total from invoices, and we're joining. So in other words, we're asking for all the invoices, including number, date, total, all right, where the vendor is from California, and we're ordering those by invoice date. So here's the same query, and you'll notice if you look at the results, they're the same, but in the second case, we're doing this as a subquery. So the first thing we do is we select the vendor ID from vendors where the state is California. So that's going to throw out everyone who's in any of the other 49 states or anybody non-California. Then we use that we use that output from here as the input to the outside part. So again, two different queries, same result. Which one's better? That's not, I've listened to people talk about stuff like this, and one of the things that I've heard, for example, when you talk about which is better, is that people will say things like, it's like asking which of your kids do you like best. In other words, you can't really answer that, and you can't really answer which of these is better. It depends on the situation. All right, sometimes it is easier to use a join. Sometimes it's easier to use a subquery. So on the slide you see right here, they give you advantages of both. Advantages of joins, they say, you can include columns from multiple tables. It can be more intuitive when you look at it. Whereas with subqueries, you can pass an aggregate value to the main query. So you can do these: sum, average, count star, min, and max. All right. Subqueries can be more intuitive depending on who you are. And then finally, long complex queries can be easier to code using subqueries. But again, more often than not, it's a matter of taste. And the chances are pretty good if you go to work someplace and you're asked to get data from somebody They're not going to say, gee, Jeff, did you do that using a subquery or did you do that doing it using a join? Because there's probably a pretty good chance, at least, that the person that you're reporting to won't have any idea what either one of those are. All right. You can use a not. So in other words, we get the distinct vendor ID from invoices, and then we use that output as input into this, but we say not in. All right? So as it says, that would end up getting you vendors that do not have any invoices. So maybe they're brand new vendors, or they're vendors that for whatever reason have never bought a product from you or provided a product for you. And as they show right there, there's the results of the subquery right there. So there's your 34 rows, okay? And then once you put that in, you're getting the vendor ID and the name and the state. Why would you want that? Well, the reason I'd want something like that is I would want to be able to go to marketing or somebody in the company and say, hey, why don't you contact these people and figure out why they're not invoicing us? All right, again, why they're either not providing products for us or buying products from us or whatever it happens to be. So here's the same thing that's put in here again without a subquery. So you can see they used it as a join. So virtually anything that you do with a subquery, you can do it using a join. And does the reverse hold true? Well, it can. All right. The problem with a lot of this stuff is that it's kind of like teaching. Most people teach to their strengths. In other words, if there's something I know pretty well, I'll probably spend more time on that than something I don't know as well. Well, in much the same way, people who naturally find joins easier will probably use joins more often, and people who dislike joins for whatever reason will probably end up using subqueries more often. All right, but that's way too general a statement. Usually, it depends on the situation. All right, notice that the where clause that's in here, you can use 3 different words with it. You can use the word some, you can use the word any, and you can use the word all. Okay? Some and any are very similar to one another. Well, let's take a look at what they say here. All right. So here we're saying X is greater than anything that's in here. Well, it's got to be greater than both of them. So you can't say X, is anything that's greater than 1 or 2. So in other words, anything that's greater than 2. Anything that's less than 1 or 2. So anything that's less than 1. So both of these must be met. And if it's equal, it has to be both equal to 1 and equal to 2. And not equal, again, would mean the same type of thing, but for unequal. So here's an example. Let's take a look at what we're doing in here. All right. We're selecting the invoice total from invoices where the vendor ID is 34. Okay? And you can see these right here. And then we're saying select the vendor name, the invoice number, the invoice total, and then join, do a join, but the invoice total has to be greater than either of these. All right? So it has to be greater than 1083.58 because when you're using all, it has to be greater than all of them. So in that case, since we're using a greater than, it must be greater than the greatest value that was returned from the subquery. In much the same way, if we used a less than in there, all right, if there was a less than right here, then it would have to be all invoice totals that were less than 116.54. Now here's any. So look at it this way, when you're working with all, everything must be, you're looking at everything in there. That's kind of like an and. Whereas when you say any, it's more like an or. All right? Now that might not be the greatest of explanations, but to me at least, that makes a little bit of sense. So in this case, we're saying less than any. And, well, what's the lowest one that we have in here? Well, less than any. And actually, now we're looking for the highest one. So anything that's less than 2567, and you notice that they all are. Now, some and all are basically pretty much the same as one another, okay? They're used pretty much the same. All right, let's change focus a little bit and talk about a correlated subquery. In a correlated subquery, again, what we talked about before, typically what happens is you run the inner query, the output from the inner query becomes the input for the outer query, okay? And that's the way it works with what's called an uncorrelated subquery. When you have a correlated subquery, it runs it once, and then it checks it. How do I explain this? I'm trying to explain it in a way that makes sense. For the first time in these lectures, I'm actually going to take a look in the book right here and see how the author explains a correlated subquery. All right, so this is a first for me. All right, so the author says, so far all of the subqueries that we've looked at have been uncorrelated subqueries. An uncorrelated subquery is executed only once for the entire query. However, you can also have a correlated subquery that's executed once for each row that's processed by the main query. This type of query is similar to having a loop to do repetitive processing like you'd have in a procedural programming language. All right, that may help, that may not help. Again, to me, I'm supplementing what's in the book. I picked out this book. If you like the book, hey, it's my fault. If you didn't like the book, hey, it's my fault. But I picked the book that I thought did the best job of explaining the things that I think are necessary for students, especially for next semester, because once we go in and we start talking about server-side languages such as PHP and ASP.NET, it's very important that you have an understanding of relational database management systems. And again, the reason that we're using MySQL is because it's free. All right, the syntax of a subquery that uses the exists operator. So in other words, select star from invoices where vendors, boom, boom, boom. So there's the result set. Okay, but where not exists, again, I'm trying to think of the best way to put all this stuff in here and explain all this stuff to you, and I'm to the point right now where I think I am going to have to go back and take a look and see how they explained it in the book. All right, the exists operator tests whether the subquery returns a result set. In other words, it sees whether a result set exists. When you use the operator, it doesn't actually return a result set. Rather, in this case, it returns true because there are some results. You typically use the exists operator with a correlated subquery. All right? And they give you an example here. The example is shown right in the book, and it's around page 203. Again, notice they show you the same query using both a subquery and with a join. All right. All right. A query that uses an inline view. Now this is really interesting. Select the state and the max number of invoices from, and then notice what they're doing. All right. It looks at least as though they are running a correlated subquery because they're going to be doing this, and then they're going to be finding out the max number for each state. So they'll be doing this for the first state, then the second state, then the third state. So if there are 50 different states in here, it's going to run that basically 50 different times. So you can see you get 34 rows back, but then you just want the biggest one from each. Here's a complex query that uses 3 subqueries. All right, so you've got what? You've got a select here, and a lot more on the next page. This is explained in the book on page 209. Again, you may or may not have heard of terms like this, but sometimes people literally talk about data mining, where the data is in there, but it literally has to be mined. In other words, it's in there, but it's buried in there so deep that you have to dig for it. All right, and that's kind of what they're showing right here. So the author kind of ends the chapter by coming up with this 4-pronged procedure for building complex queries. And it sounds really simplistic, but it actually makes sense. The problem is people want to jump into step and start on step 3. And normally if you don't do it that way, you're going to be better off in the long run. Okay? You'll have a better understanding and you'll end up writing better code from the beginning. So, state the problem to be solved by the query in English. Then go in and actually pseudocode. So outline what you want it to do. Then code the subqueries and test them to make sure they return the correct data. All right? Notice it says subquery. So again, do the inner one. Make sure that you're writing it correctly. Then work your way out, as we talked about before. Finally, code and test the final query. And that's pretty much it for Chapter 7. In just a couple minutes, I'm going to come back and go into Chapter 8, which talks about the different data types that we have available to us. I now have the latest and greatest too of the PowerPoints, so. All right, so we'll pick it up right there in just a few minutes.